Okay, so let us get started with overhead insulator. So we will be looking at properties of overhead insulator. We'll look at some of the recurring examples of insulators in various exams. Then we'll see types of insulator. In that we'll be discussing four insulators: pin type, suspension type, shackle and strain type. Then we will be looking at voltage distribution, and that we'll be looking at string efficiency calculation. So in voltage distribution, we'll be looking at a string efficiency. We'll be looking at how voltage is getting distributed, formula for V1, V2, V3. Then we will be looking at the benefits of guarding. And with that, we will wrap up this particular chapter. Okay. So let's start with the properties of overhead insulators. So we need permittivity, mechanical strength, resistance of insulator, ratio of flashover or safety factor, and dielectric of insulator all should be high. Temperature variation should be very less. Examples of prominent insulators are porcelain with a dielectric strength to be 6.4 km per millimeter, then glass 14.4 kilovolt per millimeter, and rubber. Types of insulators were pin, suspension, strain and shackle. Pin type is a very old type of insulator which is used from a very olden days, and it is used to protect, it is used for the range of 33 kV. Suspension type is also used for a range more than or equal to 33 kV. Strain type is used mostly for 11 kV and shackle type for 33 kV. Strain type and shackle type are mostly used for similar kind of application, that is wherein there are corners, curves or sharp edges. Fine. Then now coming to a very important concept of voltage distribution. So voltage distribution, the first concept we will be looking at is string efficiency. String efficiency is calculated in per phase. So in numerator you will have total voltage, that is V1 plus V2 plus V3 and so on per phase, upon N. So for 3 phase N is 3, and VPH 3 VP V3P V3PH. Okay, so basically we'll take voltage that is closest to the conductor in denominator. So it will be like V total. String efficiency is basically V per phase total upon N into V per phase V3 per phase into 100. Now there are three voltages for, yeah. So if voltage is distributed in three levels, there is the first case for three levels. So the one which is closest to conductor V3 is 1 plus 3k plus k square V1, V2 is 1 plus k V1 and V1. Okay. And what is k? K is nothing but Cs upon Cm. So you must be wondering, and you must be observing at the same time, that V1, V2, V3 are unevenly distributed. To overcome this, we follow guard ring concept. But before moving to guard ring, we'll see second case also, wherein there is only V1 and V2. So when V1 and V2 is there, V2 is always equals to 1 plus k V1. So one must always remember that it starts with V1, then 1 plus k V1, 3k plus k square plus 1 V1. Okay. So it is like, rather we can call as k square plus 3k plus 1 V1. Okay. K square plus 3k plus 1 V1. And if only two branches are there, then only the top two formulas. But it will always start from V1. Fine. Then guard ring concept. Since if you want to make that uneven voltage distribution to be even, we'll use guard ring concept. So if we short this two ends and put a capacitor there, voltage at both, the potential at both ends would be same. For example, V1 into C1x, omega C1x will be equal to potential as that point, that is V2 into Cs. If there would have been some Vx at the top, then potential at this point would be Vx plus V2 into Cs and V1 into Cx. We would equate that and we will get, and also the current going through this and this is same, right? So we can equate the current and follow the, and find out the Cx ka rating. Fine. So this is about the voltage. This is about the overhead insulator. Now one thing I want you to understand is insulation in UG cable is different from overhead insulator. Overhead insulator is the insulation to the overhead lines. UG insulation, which is inversely proportional to L, is the insulation which is outside the core. Okay, so let us quickly revise. Properties we have seen. Examples of insulators were porcelain, glass and rubber. And the one with the maximum dielectric strength was glass. Types of insulator were pin, suspension, shackle and strain. Pin, suspension, shackle type are used for above or equal to 33 kV, and strain type is used for about 11 kV. Then voltage distribution, we have seen the concept of string efficiency, where we saw percentage efficiency is equals to V total upon N into V3 per phase into 100. Then we have seen when voltages are divided into three levels, the division is V1, 1 plus K into V1, 3K plus K square plus 3K plus 1 V1, where K is nothing but CS upon Cm. Then we have seen for two division it is V1 into 1 plus K. Then we have seen that to overcome this uneven distribution of voltage, we follow the concept of gaurd ring, and we short two ends with a capacitor that makes both the voltages equal, so that further causes the current through limb 1 and limb 2 to be same, which we can equate as shown in the example, and follow the capacitance rating. Okay, so yeah, we will learn about corona and distribution system in the next chapter. Thank you.